What if the blur above Mars isn't camera noise, but the first close-up of something older than our Sun? Tonight, 3i Atlas steps out of theory and into Perseverance's viewfinder, and the light around it refuses to play by the rules. A fresh image of 3i Atlas has unveiled something genuinely bizarre. Researchers found that sunlight behaves around this object in a way unlike anything we've observed or even imagined before. Take this frame. Shot by NASA's Perseverance rover's Mastcam Z on Mars, it shows a faint, blurry blot in the Martian sky, right where scientists predicted the interstellar visitor 3i Atlas would appear. It's the first time we've seen 3i Atlas from such a close vantage point. In the picture, the comet is only a dim smear beside a cluster of stars, each around magnitude 8. Another dataset captured motion in the Martian sky that investigators attribute to 3i Atlas itself. Curiously, the photo wasn't taken at exact closest approach. Perseverance grabbed it a day early. Teams note the true closest pass could only be properly caught by Mars orbiters, but due to the current NASA shutdown, detailed close-ups may take time to surface. During 3i Atlas's near pass, Perseverance also logged heightened surface activity. Dust devils whirling near the rover and a broad dust storm brewing on the horizon. The interstellar visitor's tail isn't visible in the rover shots. It was too faint then. Scientists already flagged how unusual this comet is for its nearly invisible tail, a rarity among comets. Yet as it neared Mars, a thin tail began to appear, still far fainter and narrower than normal. Other images of 3i Atlas hint at its outline, but remain unverified. If those hold, the nucleus looks elongated, more like the first interstellar object, Oumuamua, and less like 2i Borisov. Recently, the interstellar comet 3i Atlas swept close to Mars on October 3 within about 0.19 AU, roughly 28 million kilometers. It's now tearing through space at almost 200,000 miles per hour as it descends toward perihelion, its closest point to the Sun. Then came a twist. Astronomers think 3i Atlas was struck by a coronal mass ejection, a vast surge of solar particles and energy from the Sun. After that solar blast, the comet dropped from view, likely due to growing distance and harsh solar glare. Earth's motion now carries us in the opposite direction, further smearing it into the star-rich background. Result? 3i Atlas probably won't be visible again until later this year. And just as many chalked it up as a normal comet, new observations turned up anomalies in its structure and light behavior, features that strain our current models. Astronomers have completed the first polarimetric study of the interstellar comet 3i/Atlas. When sunlight reaches a comet, it doesn't merely bounce back, it scatters. Each dust grain or ice shard acts like a tiny mirror, reshaping the light. As those waves interact with material, like a comet's dust, some ripples become organized. Instead of random directions, they align. That ordering is polarization. By measuring how strongly light is polarized and the orientation, we can infer dust size, shape, roughness, and whether it's icy, rocky, or mixed. Typically, comets show positive polarization at larger phase angles. At small phase angles, many show negative polarization. With 3i Atlas, astronomers found an exceptionally strong negative polarization, far beyond any comet yet measured. That was a shock. It implies dust near 3i Atlas is markedly different from homegrown comets, perhaps rougher, more irregular, or made of exotic materials rare in our system. This marks the first time such behavior has been recorded in an interstellar object. We've studied many local comets and a few interstellar visitors, but none share 3i Atlas's polarimetric signature. Its extreme negative polarization, dipping to negative 2.77% at a 6.4-degree phase angle, is unprecedented. This oddity hints 3i Atlas may have formed in a radically different environment, perhaps another stellar system or the frigid outskirts of our own. Some teams even argue the object predates the solar system itself. Their work suggests it likely originated in the inner galaxy, making it one of the most ancient, enigmatic travelers ever to cross our neighborhood. Another surprise, a peculiar chemical milieu surrounds this object. Measurements indicate the environment around this interstellar visitor resembles Martian atmospheric surface conditions. That strongly implies it did not arise in a typical comet nursery like those in our system. Instead, it may have been ejected from a planetary surface, possibly a world Mars-like in character. Some observers claim it glows in ways regular comets don't, implying it could evaporate intensely or even fragment near perihelion. Meanwhile, other mysteries have surfaced. We've already seen 3I Atlas shedding mass, wrapped in a visible gas coma. Ordinarily, outgassing nudges comets off course, like tiny thrusters. But 3I Atlas behaves differently. Despite the growing gas halo, its trajectory barely budges. Some researchers think this could reflect enormous mass. The way it resists recoil might mean a denser, heavier body than expected. Early estimates placed 3I Atlas at least 1,000 times more massive than a typical comet. Newer work suggests a mass exceeding 33 billion tons, staggering for a natural comet. Not only is it far more massive than previous ones, but there isn't enough rocky material in interstellar space to deliver such a giant rock into the inner solar system over the past decade. What do you mean not enough rock? What does that imply? Does it push you further toward a non-natural origin? Yes, the interstellar medium offers a limited reservoir of rocky matter per unit volume. Recently, Professor Avi Loeb sorted 3I Atlas's oddities into 2 bins. The first holds anomalies that more data might resolve: its size, the strange anti-tail, a forward jet of scattered sunlight about 10 times longer than wide, aimed sunward, its unusual chemistry, and its strong negative polarization. The second bin covers those that may remain stubborn. The trajectory of 3I Atlas aligns to within 5 degrees of the ecliptic, the flat plane where planets orbit the Sun. Another eyebrow raiser, the arrival was timed to pass near Mars, Venus, and Jupiter. Stranger still, its inbound direction sits within 9 degrees of the famed WOW signal detected on August 15, 1977, once suspected by some to be an extraterrestrial beacon. Have an excellent day, and thanks for watching. Enjoyed the video? Hit like, it really helps the channel. Subscribe and ring the bell so you don't miss new updates on 3I Atlas. Drop your theory in the comments and share this with a friend who loves space.